Let's now consider the motivating scenario for the singleton design pattern. So let's consider two example problems that we would like to solve using the singleton pattern. And we're going to discuss one of them in detail. The first one, let's talk about bank accounts with a set of shared data. For example, you may have interest rates, you may have exchange rates, minimum balance, and maximum balance. So basically, every bank account needs to share these data. Okay, but how do we share them? The second problem is just more about your operating system course. Let's say you got processes. They're going to be regulated to access some share limited resources. For example, printers. Let's say 2 printers are to be shared among maybe 55 processes, for example. Right? So these are the two typical problems where you want to have some share instances, very limited number of share instances among several other entities. But let's talk about bank account specifically for our example. Let's say we do a first attempt by using something that's not the ultimate singleton pattern solution. Let's say we use inheritance, which you know from the previous OOP course. But how do we share data using inheritance? Let's present this solution over here, and then we'll try to criticize on that to see whether that's appropriate or not. Okay, let's say we got one class called deposit. And so every instance of deposit is going to be representing some deposit transaction, for the bank account. And then it's going to inherit from shared data. And as far as the deposit is concerned, we only worry about maximum balance. There might be like a maximum 1 million that you can deposit into your accounts. It cannot be more. Similarly, let's say you got a withdrawal transaction here, also inherits from shared data. And now for the withdrawal, the only relevant attributes would be, or the only relevant data would be minimum balance. So you cannot really go below certain limits. And the third class will be international transfer, let's say. So international transfer also inherits from shared data, and the exchange rates is the only attribute that matters for international transfer. Finally, we got another class called account, let's say. The account class also inherits from shared data, and then we got deposit and we got withdrawal. And the only thing that will be relevant is called interest rate. So what we really need to pay attention to for this example here is every kind of a bank transaction or account class, there's only one attribute value that's relevant to each one of them. Meaning that if we want to use inheritance, somehow we want to inherit all these data from some common parent class, basically. And that common parent class is going to union all these attribute values together into a single place. That seems to be the way to go if you want to share data by inheritance. So that means, consequently, we have a class over here called shared data. You can see the shared data is actually the common parent class for each one of the 4 classes that we just talked about. And over here, we got interest rate, we got exchange rate, minimum balance, and maximum balance, right? And the type, just a real number and integer. So types here are not really the focus point. Okay. So now we have to criticize on this particular design. So every time before we present to you the ultimate design pattern solution, we want to see is there any other alternative way for solving the problem. Because always design problem is really open-ended. You want to know what options you have and choose the one that makes the most sense or the most beneficial solution you want. Okay, so now you may want to pause the video and think about yourself whether this inheritance solution is really good. Let me give you a little bit hints over here. You want to think about at runtime, okay? Actually, both the compiler time and the runtime. When you say this is the common parent class and each one of these simply inherit from that. So exactly what attributes do you have for each one of the class? Are they really relevant to each one of them? Number one. Number two, at the runtime. Let's say if it happens that I want to modify the interest rate, maybe from 1.1 into 1.2, for example. In that case, is it really a minimum number of places or objects I need to modify? Well, there will be a large number of them that I need to modify. So that sounds a little bit more like a single choice principle that we talked about before. Okay, so these are the 2 hints for you that you want to think about. Maybe pause the video and try to visualize what's going to happen at the runtime and also at the compile time. If these two hints I just gave to you, how will they be satisfying? Okay, assuming that you have already thought about it, so why don't we move on to iPad very quickly? Okay, so the 2 hints I just gave to you, the first one is called cohesion over here. So let me just give you a quick definition here. Cohesion simply means a class has a unifying theme of purpose, which means all the attributes or features you store in that particular class has the same purpose, or they're all relevant. All features are relevant with respect to that purpose. Okay, that's kind of the definition for cohesion over here, right? Cohesion is really the first principle we want to consider in this lecture here. Okay, unifying theme. That's really important. If you want to think about cohesion, think about your previous 2031 when you learned about the Unix operating system. So there's a well-known principle over there: do one thing and do it well, which means every command that's in the Unix system. For example, if you got the cd command over here, or ls command over here, or maybe pwd, right? So these are the individual commands in the Unix operating system. Each one of them is actually cohesive, meaning that it's only doing one thing and do it well. cd is responsible for a different task than ls does, right? And etc. So that's an analogy for you. So now let's think about, as far as cohesion is actually concerned, is our first design actually good? I mean, by inheritance. The answer is no, because, for example, if you think about it statically at the compile time, this is the common ancestor or parent class. That means every attribute over here will be inherited to every class, every subclass more precisely. So for example, if you talk about the deposit class over here, that's a subclass over here, right? So now we said that only the maximum balance would be relevant to this particular transaction for deposit. However, is maximum balance the only attribute that will be inherited to the deposit class? The answer is no, because you can see over here, these attributes over here, they will be also inherited to the deposit class. Inherited to deposit, but they are not relevant. But they are not relevant, irrelevant. So this will be a violation of cohesion. And you can apply the same reasoning for example, let's say one more. Okay, let's say for the case of, let's say, international transfer class over here. In this class, as we said before, only exchange rates will be relevant. So not only the exchange rate will be inherited to this particular international transfer class, but all the others, for example, interest rate, minimum balance, and maximum balance, they will still all be inherited to the international transfer. So all those attributes are not relevant. So this also, again, violated the cohesion. So basically what we're saying is, if you simply want to union all the shared data into a common super parent class over here, like a shared data, that's not the way to go, because only a subset of them will be relevant to a particular child class, but all the others that's inherited to the same child class will be not relevant. In that case, you're really putting relevant and irrelevant things together into a single class. That will violate cohesion. Okay, that's I hope that's a thorough explanation about cohesion here. Okay, that's the first design principle that's violating. What about the second one? We learned about also single choice principle before. So you already got the written definition in your previous slide, so I'm not going to write it down. But just to remind yourself, single choice principle simply means if there is a change on your design, there should be a minimum number of changes that should be required to really apply the new change. Only a minimum number of places. It might be more than one, that's okay, but as long as it's the minimum, will not be more than necessary. So typically, if you violate the single choice principle, that means you got duplicates in your design or in your code. But is this the case over here? Well, we already explained at the compiler time, you already violate the cohesion principle. Let's think about why at the runtime you actually violate the single choice principle, especially if you try to modify some attribute value. How can you keep it consistent among all the instances of the bank account objects? Okay, let's take a look. So let's talk about runtime right now to really explain why single choice principle will be violated. Let's now try to mix the following setup over here, right? So this is shared data class. Just for your convenience, it is still the same. Let's say we got D1 and D2, so they're simply deposit object. Let's say at the runtime, we simply say D1 is storing the address of some deposit object over here, right? That's why you see D1 is pointing to that particular object. And also we got D2 is also pointing to another deposit object. They're simply just two separate deposit transactions. Similarly, let's say we got W1 and W2. They're simply two different withdraw transactions objects. So you got W1 is pointing to this object here, and also W2 is pointing to this object over here, right? And one more. Let's say we got T1 and T2. Let's say we got T1 is pointing to some international transfer objects, right? Transfer here. And also T2 is also pointing to some international transfer object here. All of these are subclasses of shared data, just to remind you. So that means at the runtime, each one of them is going to get all the attribute values inherited, right? Each one of them is going to get interest rate, exchange rate, minimum balance, and maximum balance, right? So now let's say to begin with, their interest rate is all 0.11. And also their exchange rate is all 2.34. And all the same, right? I'll try to circle to you. So they're all the same in the initial setup. And then for minimum balance, it's all 1,000 over here. And also for the maximum balance, it's all, let's say, 1 million for all of them. Okay, so that's the initial setup. You can see all the data that's shared they are all inherited to the the child instances, and also they're consistent at the moment. So let's see how the single choice principle can be violated. That's the main point. So let's see this. For example, let's say we are saying D1.set maximum balance over here to be some new value. For example, we can set the maximum balance to be 2 million, for example, right? So now D1 is referring to this particular object over here, right? You can see D1 is referring to this particular object, and I want to modify the maximum balance to be 2 million. So now rather than 1 million, it's now going to be 2 million. So now, is this the only object I need to change in order to achieve consistency? Apparently not, because as soon as I change this 1 million to be 2 million, I only modify only D1 over here. That's the only object I modify. But all the other existing instantiations of the shared data, they must be modified as well, which means I need to change this one to be 2 million. I need to change this one to be 2 million, this one here to be 2 million, and these two as well. So you can see it's not actually trivial problem to solve, meaning that every time you change the attribute, you have to change across all the existing objects for this particular common ancestor over here. So that's the tricky part. Okay, just one more example for you. Let's say if I do W2, I change the minimum balance. Similar idea. Maybe change the minimum balance to be maybe 500, for example, right? So now after I do W2, the minimum balance, let's say from 1,000 to 500, right? So now how many places do I need to modify? It's beyond minimum. So that means I need to modify this to be 500, modify this, and also modify this. Basically all others. Imagine a complicated realistic system where you might get maybe thousands of objects instantiated throughout your system, in which case changing one of the data, you have to also make sure you change all the others, which will be a big number to really keep track of. And if you're doing this update process manually, it's going to be very error prone. So that's why it's violating the single choice principle over here, okay, at the runtime. Hopefully that's clear to you. So now, up to now, what we have said. What we have said was, if you go to the initial proposal for sharing the data using inheritance, we simply union all the possible shared data into the common ancestor class. In that case, you're going to violate at the compile time the cohesion design principle. At the runtime, you will violate the single choice principle. So make sure you understand why these two principles are violated before you move on. Okay. So this is just the architectural diagram for sharing using inheritance. You can see, as we said before, you got inheritance arrow over here. You can see all of them are simply subclasses of the shared data, which contain the union of all the possible shared data. And also you got some client-supply relations over here. Okay, and then we say irrelevant features are inherited, so that's exactly the violation for cohesion. And then we also talk about the duplicate. You can think about all these data here. You can see the same value over here for 500 over here is duplicated 6 times. Of course, we only talk about tiny system. In a big system, the same data might be duplicated many times. That's a waste of resource, and also hard, making that hard for consistency maintenance. Okay, so that's about the 2 design principles that we are violating. So now let's see how we can address them. Okay, so this is just the description for the single choice principle, right? What if the interest rate changes? Then what other objects do you have to change, right? We already illustrated it. And if you try to think about the first problem about processes, also, if you actually modify the global lock, then how can you make sure if I modify this particular lock, it's going to be visible by all the regulated processes? Similar to, if I actually modify, for example, the interest rate, if I modify that to some other value x, how can I be sure this x value is visible to this object over here, this object here, this object here, this object here, this object here, instantaneously and automatically? That's really the challenge we are trying to solve. Let's go back here. And then, so what will be the solution? The solution is going to be the singleton design pattern. That's why software engineers, they thought about this kind of problem here, and they proposed the solution that will be singleton design pattern. Okay, and we'll talk about it. Let me just sketch the solution very quickly before we talk about the details. So we're going to separate the notions between data, like interest rate, exchange rate, minimum balance, and maximum balance. Separate the data into one class, and we're gonna have another separate second class, which will only try to do share access. It's like a separation of concern, data versus the share access of the data. So they are going to belong to different classes rather than just a single one. Okay, we're gonna encapsulate the shared access itself in a separate class, and we're gonna see exactly how we do it. And we want to make sure that particular data class will only have one single instance. And the way to make it work is to really program or design the shared access class very carefully. Okay, before we can really present to you how the singleton design pattern is done, we have to talk about 2 technical background. One is about the once routines, the other one is about the export status, but we'll do one by one, and then we'll present the ultimate solution to you.